This is a continuation of the parabola video, split into two parts. The first time we were doing vertical parabolas, which were of the form y equals ax minus h squared plus k. So a vertical parabola would look like, for example, this, or it could be upside down. Today we're going to do horizontal parabolas. These are parabolas that look like this. The reality is our coordinate systems are arbitrary, so the equations are going to look very similar. And in fact, in general, oops, that's a total mistake there. Should look that way. You could just flip the coordinate systems and use the same equations. But in general, when you're dealing with things like gravity, you want something to look like this, just because you're used to things. Throw something up, it comes back down. And use these for things like lenses. Generally, if you're having an eye, you want the light to come in this way, not from above. But again, it's fairly arbitrary. So don't get too wrapped up in the difference between these two. The equations will look slightly different, but the methodology you'll see is very, very similar. Okay, so the equation for a horizontal parabola, which is what we're going to focus on today, rather than the vertical ones. I should leave this up here just as comparison. Is x equals a y minus k squared plus h. Okay, so if you look at this, the difference is the h's and basically the x and y's have been flipped throughout. You flip the y and the x to the x and the y here. You flip the h where the k was, and the k where the h was. So you just basically flip both the variables and the vertex locations. But you can see they're quite similar in form. Easy to get mixed up though, so make sure you have it down on paper and you have it on one sheet next to each other so you can make sure you use the right one. Okay, and other things, C, focal length, is still 1 over 4a, and therefore a is still 1 over 4c. That doesn't change. The actual focus equations and directrix equations do change. The directrix equations will now be x equals rather than y equals. Here it was y equals. And the equations actually will change for the focus as well, but that's not, we're going to do it with equations, we're going to do it by graph. Okay, so now I'm going to graph a basic one first, which is x equals y squared. I'm going to plug in values of x and get values of y. So just so I can graph it. So you're going to find it's very similar. If I plug in an x of, for example, 0, I'm going to get a y of 0. If I, however, plug in x of 1, I get 1 equals y squared, and y is plus or minus 1. 2 points. 1 plus or minus 1. I'm going to skip to 4, and you'll see why in a moment. If I put x is 4 in here, I get y squared is 4. And therefore y is plus or minus 2. So that's over here. Now that was probably an unnecessary piece of analysis because all it is the same parabola we had before, except rotated 90 degrees. This one here has an a of 1. It's positive. If it's an a of negative, it'll be going this way. So this is a equals 1. If I had a equals negative 1, like x equals negative y squared, for example, this is x equals y squared. It would be over here. And again, the way we graphed last time with horizontals, just do the same thing. It's over 1, that's up 1 over 1, up 2 over 4, that's a 1. If it was 2, it would be up 1 over 2, up 2 over 8. Just think of the same thing we were doing before, except flipping at 90 degrees. Okay, so there we go. There's my, raise this up here. I'm going to do the directrix and such. Okay, remember we were doing x equals y squared. Okay, so the focal length is still the same. I was saying vertex first. Vertex is just 0, 0 in this case. It's y minus k. There's no k there, so it's 0, and there's no h on the outside, so it's 0, 0. Shows it right there. The focal length is 1 over 4a, which is a quarter again. Except now, to find the focus, you just go a quarter to to the right inside the parabola again. So that becomes 1/4, 0. Just put the point on and then find out what the point is using coordinate geometry. And then the directrix, remember, is going to be x equals in this case, but just go 1/4 on the other side, and you're at -1/4. And finally, the axis of symmetry is simply the x-axis, which is y equals 0. So notice the axis of symmetry also changed its equation, but it's still basic, same idea. I wouldn't do it with the equations, just do it graphically. If it's a sideways parabola, put the parabola sideways, the focal length will go inside it, the directrix will go outside, and then you get the equations just by looking at the graph. Okay, a little more complex one. I'll give myself a little more room here as well. I'll continue to write this up here, so at least I have this as reference. X equals y minus k squared plus h. Okay, so now I'm going to do another one. I'm going to do x equals y minus 3 squared plus 2. Okay, so first step is the vertex. Remember, they're flipped. So this is the x coordinate right there, 2. There's the y coordinate of the vertex, 3. And remember to change the sign there. So it's 2, 3. It's very easy to mix up, by the way, as you can see. Because in the other one, you had to read this one first, then this one. This one, you got to read this one first, then that one. So it's 2, 3. A is 1 again. So it's just, this time you're going this way. It's over 1, up 2, over 4. And the same thing symmetrically on the other side. Like so. Then we do the focus. The focal length is simply 1/4 again, because A is 1. Focus, I'm going to draw it in, is 1/4 inside here, which is 2 1/4. And then it's right on the axis of symmetry, so it's 3. And the directrix is x equals, it's 1/4 on the other side, so it's 1 3/4. X equals. And the axis of symmetry is y equals, and in this case just 3. Alright, let's try one more. This time I'm going to make it a little more complex in terms of A. It's the only thing I can really change. I'm going to leave all this stuff on here so I don't have to rewrite it. So x equals -2 y plus 4 squared minus 2. Okay, so vertex, again, start here. -2, -4. -2, -4. There's my vertex. Focal length, it's 2 now, so it's C is an eighth. For the formulas, it would come out -1/8, but it's a length. So it's an eighth. Oh, actually, let me draw it first. It's also 2, so that means, and it's -2. That means it's going this way. It's reflected from the positive one, which goes that way. So it's over 1 up 2, or left 2, over 2 left 8, 4, 6, 8. Mirror imaged. And there it is. Okay, focal length is an eighth, which means it's right on the side by an eighth. So the focal point, or the focus, is -2 1/8. And it's down to -4, that doesn't change. The directrix is on this side, it's x equals, and it's not 2, but short of an eighth of that, so it's -1 7/8. And then the axis of symmetry is y equals -4. Okay, I'm going to have you guys try one, and then we'll call it. I'm going to erase this again, just so I don't have to rewrite it again. Okay, here's the one we're going to try. X equals y plus 4. Let's put a 2 in front of that. Squared. There we go. Okay, pause the video there. Try to plot that and do all of these. All right, you're back. We'll start with the vertex. H doesn't have a value, which means it's 0. So that's 0, -4. So it's down here. The focal length is still an eighth. It's 2 in front. Let me graph it first. 2, positive, which means it goes this way. Over 1, up 2, over 2, over 8. Yeah, there you go. And same thing symmetrically on the other side. And there we go. Focal length is an eighth, so it's right inside there. So the focus is simply 1/8 over and -4 down. The directrix is on the other side. X equals -1/8. And the axis symmetry is y equals -4. Okay, maybe try one more. Just to make it a little trickier, I'm going to put a half in the front and see if you can figure it out. One half and y minus 3 squared plus 5. Okay, pause the video there, try to do, again, graph that and do these 5 things. Okay, if you're back, we'll start with the vertex. Vertex is 5, 3. So plot that first. 1, 2, 3, 4, 5, 3. Now the only tricky part is graphing it. It's a positive half, so it's going this way again, to the right. Opens up to the right. If you go over 1, you go up instead of 1, you go right a half. If you're over 2, remember you're supposed to go to the right 4. It's half of 4, so you go over 2. And symmetrically again, half, 2. And you can see the half, what it does is it actually flattens the parabola. It's starting to look more almost like the shape of your eye. I think your eye does have close to a half as a, your lens of your eye has like close to a half as a, an A value. Okay, now we'll do focal length. This is a little tricky. It's C equals 1 over 4 times a half, which is 1 over 2, or a half. So it's right there. The focus is now 1, 2, 3, 4, 5 and a half, and 3. The directrix is on the other side by a half, so that's 4.5, or x equals 4.5, and the axis symmetry is y equals 3. All right, that's it. Let me summarize all of it for both sections. So this is for parabolas. You have horizontal, I'll start with actually the one we did yesterday. We'll have vertical parabolas, which are of the form y equals a x minus h squared plus k. You have horizontal parabolas, that doesn't really look like parabolas. There we go. Which are x equals a y minus k squared plus h. The first thing you should do, by the way, when you're doing these is make sure which one you have, because this one you go hk and this one you go hk. And this one obviously will be up down, and this one will be, I should draw that, up down, and this one will be left or right. Okay, focal length, just a couple things on here. Vertex is hk for both of them. Focal length for both of them is C is 1 over 4a. If it's the other thing is if this is positive a, this is negative a, this is positive a, that's negative a. The other ones you can only do really graphically unless I want to write every equation down, which I'm not going to do. So that's a good summary there. For homework, for geometry, just finish the worksheet on parabolas. It has a mix of horizontal and vertical ones. For college algebra, this is sufficient material for you to finish homework 29. Recognize homework 29 actually has 3 different videos you have to watch, so sorry about that. Okay, that's it. Until next time, thanks.